We are looking at the practice internal. So let's have a look. Okay, so during the quadrilateral task, 2 credits, the first thing you do is you'd fill in your name and your teacher. So for me, you could just put JS. Alright, so this is what's going to get filled in after your practice internal has been marked. Now, we have a whole lot of useful formulae. So these will come in handy later on. And we've also got a link to GeoGebra. So that'll also be very useful. Alright, so having a read of this, we're using coordinate geometry to look at a shape. So what we've got is we've got a quadrilateral UVWX. So UVWX are all the vertices or points, and here they are. So the first thing that I'd recommend doing is opening up GeoGebra and actually plotting the points in. So our first point U is equal to -1 and 8. So I just plot it in like that. Our next point V is equal to 6, 10. Our next point W is equal to 4, 3. And the last point X is equal to -4, 0. Okay, so I'm going to zoom out, and it looks like I have maybe a rhombus, maybe a parallelogram, maybe a kite. Anyway, we're going to copy that screenshot, and we're going to put that in here. Okay, I'm just going to crop that so you can see it a bit clearer. Okay, so now we've got an idea of what we're dealing with. Alright, so we've got our shape. Now the first thing that I'm going to do is I'm going to start looking at the different lines that we have here. Okay, so our first line that I'm going to investigate is the line from U to V. So we have U, and we've got that as -1, 8, and then we've got V. So we've got a line UV, so we've got -1, 8, and we've got V, which is 6, 10. So what I'm going to say is I'm going to say that our x1, so how I'm making this go smaller is I'm going control, comma. So x1, so control, comma makes it small, is equal to -1. And then our y1 is equal to 8. And then we have our x2 is equal to 6, and then our y2 is equal to 10. Okay, so we've got our x1, our y1, our x2, and our y2. Okay, so what we're going to do now is we're going to look at the gradient of UV. Now, what I'm going to do for my gradient is I'm going to use my gradient formula. So what I'm going to do is I'm just going to copy the formula from up here. I'm just going to paste it in here. It's a bit small, so I'm going to enlarge that font a bit. Right, so what we can do is we can just start plugging it straight in the formula. So my y2, now you could use y1 first, but then you've got to make sure that you use x1 first in the denominator. Anyway, we're just going to follow this formula. So y2 is 10, y1 is negative 1, oh sorry, y1 is 8, and then our x2 is 6, and then our x1 is negative 1. Okay, now what I'm going to do is I could work that out algebraically and see that that's 2 divided by 7, but just to make sure, I can also open up a calculator just so we can double check our working. Okay, so the top is 10 minus 8, and then we're dividing by 6 minus negative 1, 6 minus negative 1. Alright, now minus negative 1 is the same as 6 plus 1. So we're going to have 6 plus 1 like that. And then we have our answer as 0.2857. Rounding that to 2 decimal places, we've got 0.28. Next number is 5. So that means if we round it to 2, the 8 is going to go to 9. So it's going to be 0.29. So our first answer here is 0.29 to 2 dp. Okay, so we've got our gradient. Now the next thing we're going to get is we're going to get our distance. And what we're using is we're using the distance formula. So I can copy that. So our x2 is 6. Our x1 is negative 1. Our y2 is 10. And our y1 is 8. Okay, so if I put all of that in a calculator, I am going to get so I'm going to clear this. The first thing is I'm going to square root, and then in our first bracket we've got 6, take away negative 1, which is the same as 6 plus 1, and then I'm going to square that, and then I'm adding 10, take away 8, and I'm squaring that, and our answer is 7.28 to 2 dp. So our answer is 7.28, and that is 2 dp. Awesome, so we have our line UV, we have our gradient, and we have our distance. Right, now the next thing that we're going to do is we're going to do for the line VW. So what we could do, tab another line down, and I'm just going to change this to VW. So VW, VW, VW. Now for VW, what are we doing? So we've got our V and we've got our W. So we've got V and W. So for our X1 we have 6, for our Y1 we have 10, for our X2 we have 4, and for our Y2 we have 3. Okay, so then in our distance formula we have Y2, which is 3, minus Y1, which is 10, and then we have our X2, which is 4, minus our y2, which is 10. So I can delete this. So we've got y2 minus y1 over x2 minus, x2 minus x1. That's why it's good to check. And we'll put that in the calculator to see what happens. So we have 3 take away 10 divided by 4 take away 6. And the answer is 3.5. That isn't rounded to any decimal places, so we can just leave the answer as that. Right, now the distance. The distance, what we're going to do is, so we're going to copy the distance formula again, and our x2, so that is 4, our x1 is 6, our y2 is 3, and our y1 is 10. Right. Now if I put that in the calculator, I'm going to get, so putting that in the calculator gives us, so I'm going to go to the square root of 4 minus 6, and then squared, plus 3 minus 10 squared. So that equals 7.28. Or, is that correctly rounded? Yes, 7.28 to 2dp. So that's equal to 7.28 2dp. Alright, so now the next line we're looking at. So we're looking at the line, so we've done BW, UV, so we've done UV, BW, we're going to do WX. So we're going to do line WX, and so WX, so we've got W and our X. And then, so we've got our x1 here is 4, our y1 is 3, our x2 is negative 4, and our y2 is 0. Okay, so then using our gradient formula, here, so our y2 is 0, our y1 is 3, our x2 is negative 4, and our x1 is 4. Okay, so put that in the calculator. We have 0 minus 3 divided by negative 4 take away 4, and the answer is 0.375 or 0.38 to 2 dp. Alright, so that's our gradient there. And then our distance, again using the distance formula. So our distance formula here, our x2 is x2 is negative 4, our x1 is 4, our y2 is 0, and our y1 is 3. So the answer to that calculation is square root of negative 4 take away 4 squared plus negative 4 take away 4 0 take away 3 squared, and the answer is 8.54 rounding to 2 dp. The answer is 8.54. To 2 dp. Okay, so that's line WX. Now finally, we're looking at the line, last line is XU, or UX. So we're looking at XU, or UX, and so our U is, what's our U? So our U is 1,8. And our X is negative 4, 0. So we have our X1 is negative 1, our Y1 is 8, our X2 is negative 4, and our Y2 is 0. First thing we'll do is the midpoint. Not the midpoint, sorry. We're going to look at the gradient here. So looking at the gradient, making it a bit bigger. Our Y2 is 0, our Y1 is 8, our X2 is negative 4, and our X1 is negative 1. So that is equal to 0 minus 8 divided by negative 4, take away negative 1, so it's going to be negative 4 plus 1. And the answer here is 2.67, rounding to 2 dp. So the answer is 2.67 to 2 dp. Alright, now finally, we're going to do the distance. So our distance between 2 points now our x2 is negative 4, our x1 is negative 1, our y2 is 0, and our y1 is 8. So we have square root of negative 4, take away negative 1, so plus 1, squared, plus 0, take away 8, squared, and the answer here is 8.54. Answer is 8.54, and that again is to 2 dp. Alright, so we have completed all of our calculations. so far. Okay, what I'm going to do is I'm going to insert a bit of a table. So what I'm going to look at in this table is I'm going to look at our different lines. Okay, so we've got our first line, which is, what's our first line? UV. And then we've got our next line, which is VW. We've got our next line, which is WX. And we've got our last line, which is UX. Okay, so we've got all our lines there. Now what we're going to look at is we're going to look at distances and then the gradients of these lines. So what I'm going to do is I'm just going to copy in the distance for UV. So distance for UV was 7.28. 7.28. Now the gradient of UV. Distance of UV, gradient of UV was 0.29. 29. Distance of VW, 7.28. 7.28. And the gradient was 3.5. Right, now the distance of WX. Distance of WX was 8.54. Oh, 8.54. And then the gradient was 0.38. And now finally the distance of UX was 8.54 as well. And the gradient was 2.67. All of these are rounded to 2dp as well. Okay, now I'm going to look parallel. So what I'm looking at is line UV parallel to any other lines. And as we can see, because 0.29 is not in any of these other ones, parallel to nothing. 3.5, also not parallel to anything. 0.38, also not parallel to anything. And 2.67, also not parallel to anything. Okay, so what we're going to write now is we're going to write a little conclusion here. And that conclusion is that the shape has two pairs of sides that are the same. So that's UV WX and UV VW and the other pair is WX UX. The shape has two pairs of sides that are the same. The shape has no parallel lines because no gradients are the same. And then what that means is if there are no gradients that are the same and there are two pairs of sides that are the same, the shape must be a kite. We don't have to work out perpendicular lines in this case because for a kite and because of these restraints it doesn't actually matter. But if it was another shape that we're investigating, say it looked like it was going to be a square or a rectangle, we would then have to investigate whether or not the perpendicular sides or whether there were any perpendicular sides. How we could do this is we could add another row here, perpendicular, and then we could multiply these out. So 0.29 multiplied by any of these others. But because they're all positive, say, for example, 0.29 times 3.5, we know the answer is going to be a positive number, and the condition for a perpendicular line is that the two gradients multiplied together give a negative number. So there are no perpendicular lines. I'll put this in here. There are no perpendicular lines because all the gradients are positive, and two positive numbers multiplied together give a positive number. So M1 times M2 is not equal to -1. I'm just going to be a bit flashy and put some characters in. So the first one I'm going to put in multiply. The second one I'm going to put in is not equal. Cool. Alright, so this shows relational thinking. Now what we're going to do, next part, is we're going to look at some of the diagonals. So what I'm going to do here is I'm just going to start a new table, and I'm going to look at the diagonals of the shape. So if we go back up to the shape, we've got the diagonals UW and VX. So what we're going to look at is we're going to look at the gradient of UW. Let's start by doing that. Okay, so I'm going to say the gradient of UW is equal to, let's put our formula in, actually let's gradient of UW, so let's go again, line of UW, so U is -1, 8, and W is 4, 3. So we can have our X, we can have our X1 is equal to -1. We can have our Y1 equal to 8. And we can have our X2 is equal to 4. And our Y2 is equal to 3. Okay, so gradient of UW. Copy the gradient formula again. The gradient of UW is, well, that's not the gradient formula. Okay, I'll try again. So the gradient of UW, here we go. So we've got Y2 minus Y1 So our y2 is 3, our y1 is 8, and our x2 is 4, and our x1 is -1. Okay, now putting this in a calculator, so we've got 3 minus 8. Remember to do the brackets. We need to remember to do the brackets, otherwise using BEDMAS it won't work. And 4 take away -1, which is the same as 4 plus 1. So our answer is -1. So the gradient here is -1. Alright, so we've got our gradient of UW. Now split it into two boxes here because the second part is I'm going to look at the line of Vx. Because the line of Vx is the other diagonal. Okay, and Vx, I'm just going to copy this. So we're looking at V and X. And so our x1 in this case is 6, our y1 is 10, our x2 is -4, and our y2 is 0. So we're looking at the gradient of Vx, and so we have our y2 minus our y1 divided by our x2 minus our x1. Alright, so putting it in the calculator, we have, remembering the brackets, 0 minus 10 divided by -4 minus 6. Our answer gives us 1. Okay, so we have 1 and -1. So what this means is the diagonal lines are perpendicular because the gradient of UW is equal to the gradient of Vx. So we've figured out that the gradients are, they're not equal to each other, they're perpendicular. So that means that when you multiply the gradients together, so the gradients multiplied together are equal to -1, because -1 times 1 is equal to -1. So the gradient of the lines multiplied together means the lines are perpendicular. Alright, now the next part is we're going to look at the point of intersection between the two lines. So what we've got is, well, before we do the point of intersection, what we need to do is we're going to look up the equation of the two lines. So what I'm actually going to do is I'm going to insert a row below here. So equation of UW. Okay, so our formula of a line is y equals mx plus c. Okay, so what we've got is we have our gradient of m is equal to -1. And now we need to substitute in a y and an x. So what we can choose is we can choose a y and an x from either the point u or the point w. So if I was to choose one from the point W, so our y there is 3, so I'm going to say 3, so I'm just substituting in for that y, and that is equal to -1, and then our x that I'm substituting in is 4, and then plus c. So solving this, I'll be able to find out what c is. So we've got 3 is equal to -4 plus c, and then if I add 4 to both sides, I'm going to get that 4 over there, so I'm going to get 7 is equal to c. So we have found out our y-intercept. So the equation of this line is going to be y equals to mx plus c. Our m is -1, x plus our c is 7. Don't need to have the -1 because we are mathematicians, we're lazy, we're just going to write it like that. So our equation of uw is y equals -x plus 7. Now we're going to look at the equation of vx. Same again, we have our y equals mx plus c. Then we are going to find out that we have substituting a gradient of 1. So gradient of 1 from there. And then we're now going to substitute in a y and x. On this side with x2 and y2, we could have done x1 and y1. So here I'm going to do x1 and y1 just to show you that both ways work. So our y1 is 10, and then 1. Our x1 is 6 plus c. So when we work that out, we have 6 plus c, because we're just multiplying 1 by 6 there. And then what we're going to do is we're going to subtract. We subtract 6 from both sides. So we have 4 equals c, which means we have y equals m times x plus our y-intercept of c. So we just have y equals x plus 4 as our equation of the line. Okay, so we have our two equations. Now finally we're going to find out the point of intersection. So we've got our line for UW and our equation of the line for Vx. So one way of finding the point of intersection is we can just substitute for y. So substituting for y means that we have one side equaling the other, because our y is equal to that and our y is also equal to that. So that means that these two things are equal. So we have negative x plus 7 equals x plus 4. Okay, now what we can do is we can add x to both sides. So then we have 7 equals 2x plus 4. Now the next step is we could subtract 4 from both sides, because we're trying to get the x by itself. Finally, we want to get the 2 over there. So we're going to go 3 divided by 2, which is 1.5. So 1.5 is equal to x. Now, if x is equal to 1.5, our y, we can choose y equals x plus 4. We can substitute in there. So then our y is going to equal to 1.5 plus 4. So our y is going to equal to 5.5. I chose y equals x plus 4 because that looked easier than going negative x plus 7. But I could have done negative x plus 7 as well, and that would have been negative 1.5 plus 7, which would have given us the same answer of 5.5. So that means the lines intersect at the point 1.5 and at the point 5.5. So we have just worked out where the lines intersect. Okay, now finally I could start checking all of this on GeoGebra. So I clicked on the polygon tool. I've made the shape there. Okay. These little U, V, W, and X's sort of getting in the way, so I'm going to hide those. Hide those, hide those. Oh. Hide this one as well. Alright, now first thing I'm going to check is I'm going to check the distances. 7.28, awesome, 7.28, awesome, 8.54 and 8.54, cool, so those are all the distances that I had. Now my slopes or my gradients, 0.29, I'll check that in a second when I zoom up, 0.38 and 2.67, awesome, so because they're all positive, we know there can't be any perpendicular lines and none of them are the same, so no parallel lines. Cool, so that is all good. Now finally what I'm going to do is I'm going to work out the lines of the diagonals. So we've got that line there, and we have this line here. Now I want to find out what the equation of these lines are, so I'm going to click the value. So we've got x plus y equals 7, which is the same as y equals negative x plus 7. And then the equation of this line, I'm going to click there, I'm just going to click value, and we've got x plus y equals 4. Now that's the same, negative x plus y equals 4, and that's the same as y equals x plus 4 when we move the x over. Awesome, so both of these lines are the same. And now finally, I'm going to find out where these two lines intersect. They intersect at the point B, which is 1.5 and 5.5, and that matches up with our answer. Awesome. Okay. Finally, what we could do is we could work out that the midpoint of UV, so if we look at the midpoint there, the midpoint of UV is also the intersect of those lines. However, the midpoint of Vx, it's the midpoint of Vx is, try that again, midpoint, so I'm going to go midpoint of Vx is not the same as B. So the midpoint is the same as the intersection between VW, but the midpoint of XV is not the same as the point B there. So we have completed investigating the properties of the diagonals, and we have shown extended abstract thinking. Awesome.